Hi, and welcome to another edition of Admiral Science. I'm your host, Mr. Allen, and this is the 8th grade physical science class at Cardog Middle School. Alright, so today we're going to be discussing covalent bonds. Alright, so with our covalent bonds, we're discussing what we already know first, and what we should already know after a couple of segments is what are valence electrons. And valence electrons are the electrons on the outermost energy level. So when we make our Bohr models, remember our Bohr models, when we make our Bohr models and you do your circles around the nucleus, the number of electrons on the outside, the last energy level, those are called your valence electrons. Alright? And one easy way to know valence electrons that we tell our students is to look at the periodic table. And the groups that they are in, remember we have a total of 18 groups. And if we focus on groups 1, 2, and 13 through 18, you can easily find out the number of valence electrons, because remember, valence electrons are what is important in the chemical bonds. So chemical bonds rely on the valence electrons. So if we label all our groups as we see here, this is group 1 on the periodic table, group 2, group 3, group 13, group 14, group 15, group 16, group 17, and group 18. And if we look at lithium, which is in group 1, all the elements in group 1 have one valence electron, which means they have one electron on their outermost, the furthest away from the nucleus shell. So one electron is on the last energy level. For all the elements in group 2, 2 electrons on the last energy level. Then we will look at group 13. Once you get to the double digits, you look at the second digit. You look at the second digit, the second digit, the second digit, the second digit, the second digit. So all the elements in group 13 have 3 valence electrons. For 14, 4 valence electrons. For 15, 5 valence electrons. For 16, 6 valence electrons. For 17, 7 valence electrons. And for 18, 8 valence electrons. So this is the electrons on the outside. And these are our Lewis dot structures, and they tell us the valence electrons, because valence electrons is very important in chemical bonds, because that's where our chemical bonds occur. Alright, and everybody wants to be like group 18. This is a complete set. So all the elements have a complete set of valence electrons, but except for the exception of helium. Helium has 2, but remember, on our first orbit, let's say that this is the nucleus. On the first orbit, they can have a maximum of 2, and because helium only have 1 orbit, it has a maximum of 2, but it is still complete. It is in group 18. It is complete, just that it's complete with 2 electrons. So everybody wants to be like group 18, because the magic number is 8. Except for helium and hydrogen, their magic number is 2. But the magic number is 8. And all these elements right here, these elements with the 1, 2, 3, 4, 5, 6, 7 valence electrons, they want to be like 8. So what we already know, we learned on our previous segment about ionic bonds. Alright? And we know that ionic bonds are formed when a metal meets a non-metal. And these streaks are bugging me. I don't know where they're coming from, but let me see. Maybe it's the way I'm writing. But lithium is a metal, alright, and it's in group 1, so it has 1 valence electron. Alright. Fluorine is a non-metal. It's in group 17, so it has 7 valence electrons. Alright? And remember, everybody wants to be complete. Alright? Everybody wants to feel complete. So the magic number for fluorine is 8. And so I often tell my students, if we see here that lithium has 1 valence electron, fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons, is it easier for lithium to get 7 electrons or for simply fluorine to get 1? And most of us will agree that it's easier for fluorine to get 1 valence electron. And so if you look over here, once fluorine has the 1 valence electron from lithium, it is now complete on its outside. And because you took away that 1, and now this whole orbit gets to disappear because it's empty, lithium is now complete like helium, and it has 2 valence electrons. And so when you take away a negative, as I tell my students, if you take away the negatives baggage out your life, you then become a positive person. So does elements. If you take away the negative, it then becomes positive. But if you add negatives, you then become negative. All right? So, we know ionic bonds occur between metals and nonmetals. We know that they occur between ions. Ions are elements that have lost or gained an electron. Just like we just saw here, lithium became a positive ion when it gave fluorine its electron, and fluorine became a negative ion when it gained an electron. Alright, so it occurs between these type of charged particles, and because opposites attract, they're able to form a bond together. Alright, now what we're going to talk about today is covalent bonds. And covalent bonds happen between nonmetals and other nonmetals. Alright? They're not as strong as ionic bonds, and their electrons are shared rather than lost or gained. So if we see here, in an ionic bond, these elements, all over here, these elements with the exception of hydrogen, these elements form ionic bonds with these elements. Alright, so these are the metals, and these are our non-metals. And them markers keep popping up. I'm going to erase it over here. There we go. Alright, and these are our non-metals. Alright, and our ionic bonds happen when we have metals coming in contact with non-metals. Alright, because our metals give our non-metals the valence electrons they need to be complete, and then when they give away to their valence electrons to be complete, they themselves then become complete. But in covalent bonds, covalent bonds our covalent bonds happen when nonmetals, including hydrogen, meet other nonmetals, and they share electrons, so they like each other enough to share electrons so that they can be like group 18. Now group 18 does not react. Group 18 is already complete. So it's not involved in covalent bonds or ionic bonds. It's complete. It really doesn't need anyone else. It completes itself. Alright, so these are the elements that are complete. All the other elements want to be like group 18. Just like everybody wants to be like Michael Jordan, they want to be like group 18. Alright, so in ionic compounds, the metal element gives their electrons to the nonmetals. And if we look down here at sodium chloride, which is also known as salt, once this electron then comes over here and completes chlorine, this whole row is now empty. So you can basically just wipe it out because it's empty now, so it doesn't really matter. So then, once that row is empty, these now become your valence electrons. And if you count 1, 2, 3, 4, 5, 6, 7, 8. Sodium has that magic number of 8 now, and it is now because it lost an electron and now becomes positive. And Chlorine now has 1, 2, 3, 4, 5, 6, 7, 8. It now reached its magic number of 8, and it becomes negative. Opposites attract, and now we have an ionic compound. That is horrible. Alright. Now with covalent, they share electrons. So remember how hydrogen has 1 electron, and this hydrogen also has 1 electron, and the number of electrons for oxygen, I'm going to write up here because this is red, is 6. Alright, so together, with them sharing electrons, hydrogen achieves its maximum quota of 2, and oxygen achieves its maximum quota of 8. So now they're complete. So with covalent bonds, they form when atoms share 1 or more pairs of electrons. Alright, nonmetals and nonmetals. Alright, on the periodic table is nonmetals and nonmetals that make covalent bonds. So some of the properties is covalent bonds do not dissolve in water. So for example, wax and wax and lava lamps, they're made up of covalent bonds, and you can see, as we know, the wax simply moves about. It does not dissolve in the water. It simply just moves up and down with the heat, and it just goes up and down. It doesn't mix well with water. It's sort of like oil. Oil is a covalent bond as well as water is a covalent bond, so they don't mix well together. Unlike salt, which salt is a ionic bond and is easily broken up or soluble in water. Alright, so then covalent bond, because they don't have as strong a bond as ionic compounds, they have lower melting points and boiling points. But unlike in ionic bonds where they break apart, covalent bonds simply separate. They separate the molecules. So you have joining molecules together. Once you heat them up or boil, they simply separate until they cool down, and then they can join them back together. That's why we have, when you see water and it condenses, once it cools, it then can form bonds back, and then the water, you have water vapor elsewhere once it breaks apart. Alright, and then we know that electrical conductivity is very poor with covalent bonds. Most covalent bonds are poor conductors of electricity. Unlike ions, which are charged, remember we have a positive or a negative ion, the molecules of compounds of covalent bonds are neutral. They're neutral. That means they have no charge. No charge. They are balanced out. They have no charge. So let's compare and contrast covalent versus ionic. In ionic bonds, and please be careful where you write this information at. Double check your paper. But in ionic bonds, they're soluble in water, while covalent bonds are not soluble in water. In ionic bonds, they have high melting points. Covalent bonds, low melting points. In ionic bonds, they have high boiling points. Covalent bonds, low boiling points. In ionic bonds, they have charged particles, positive or negative. In molecules, in covalent bonds, the molecules are neutral. Alright? In ionic bonds, they conduct electricity as a liquid or in liquid solutions. And in covalent bonds, no matter what, they do not conduct electricity well. Because, again, points to this, they're neutral. In ionic bonds, they result from gaining or losing an electron. This goes back to the charged particles. If you gain an electron, you become negative. Remember, if you gain negativity, you become negative. If you lose electron, if you lose negatives, you then become positive. Alright? And in covalent bonds, think of the word co, like cooperate. They share electrons. Alright? And ionic bonds form between metals and non-metals. Covalent bonds form between non-metals and non-metals. Alright? So again, remember, if you cannot remember, ionic bonds form between metals and non-metals. Sodium is a metal. Chlorine is a non-metal. Whereas in covalent bonds, is non-metal. Hydrogens are non-metal. Think about the gas hydrogen, and oxygen is also a gas, is a non-metal. Alright, and that's how covalent bonds happen. This is H2O, because remember earlier we said that hydrogen has that one electron to give. It's in group 1, so it has one electron to give. And this hydrogen also has the same thing, one electron to give. And these are the valence electrons for oxygen. It has a 6 valence electron. So if they share, now they're going to share this electron together, and then hydrogen is now complete, and then oxygen gets to share the the electron of hydrogen. So it's now complete because here's number 7 because it's sharing with the hydrogen, and number 8. And for hydrogen, this is number 1 and number 2. Remember, hydrogen's magic number is 2. Alright, so these two are complete and with their maximum number, and oxygen is complete with its maximum number. Alright, so determine if it's an ionic bond or a covalent bond. Alright, so remember our periodic table. Alright, so we have our non-metals and our metals. So let's look. Alright, so element 1 is Na. And I apologize that this N should be lowercase, but Na. So with this, let's locate Na. And Na is right here. Alright, and it's a metal because it's in the blue area, so it's a metal. And fluorine is a non-metal. So its bond will be ionic. Alright, Fe. Fe is a metal, and it's going to bond with bromine, which is also a non-metal. So this again, our metal, non-metal. Our metal and non-metal. Alright, nitrogen is a non-metal. It's in the air that you breathe. Oxygen is a non-metal, also in the air that you breathe. So a non-metal and a non-metal, if we remember, a non-metal and a non-metal form a covalent, and I do apologize for the streaks, covalent bond. Alright, hydrogen is a non-metal. Carbon is also a non-metal. And this will form a covalent bond. Alright, so let's look at potassium. Potassium on the periodic table is a metal, and phosphorus is a non-metal. So that will form a ionic bond. So tomorrow you will be receiving a quiz, and it's going to ask you to determine if it's an ionic bond or a covalent bond. Alright, remember ionic bonds are metals and non-metals. Covalent are non-metals and non-metals. Alright, so remember this area, if it's in this area, it's in the blue area. Well, I'm sorry that this tab is making me do crazy things, but if it's in this metal, it's a metal. And so I think I need to get a new tablet, don't you guys think? Alright, and this area right here is a non-metal. And don't forget that hydrogen is over here, it too is a non-metal. And the purple are our metalloids. All right, thank you for viewing. Any questions, please leave them in the comment section below. Don't forget to comment if you have any questions. And breaking news is just in, our science class now has Edmodo. You will get your passwords to the account tomorrow. You will be getting the password to create your accounts tomorrow. And project I do soon. Don't forget October the 6th. All right. Thank you for viewing. This has been another edition of Admiral Science. I look forward to speaking with you. If you have any suggestions about the videos or how to make it or how I can improve on it, please do not hesitate to ask or give me a suggestion. I'm welcome to it. This is our first year working with the flipped classroom model. So if you have any suggestions, I'll be looking forward to hearing from you. All right. Have a good one. Remember, covalent ionic bonds. Thank you.